I'm Nell. I currently am based in Belgium, but I'm originally from Northern Ireland, and I've been working and using machine intelligence for many years in a number of different projects, both business ventures and a lot of open source projects as well. And we are seeing incredibly fast and incredibly powerful developments in machine intelligence over the last couple of years. The question I want to ask now is, why is all this happening today? Why not 10 years ago or 10 years in the future? To begin to answer that question, we need to think about human intelligence and basic human intelligence that develops and expands 2% day by day by day. This tiny brain is capable of all sorts of incredible tasks, from understanding speech to learning how to inhabit the body and how to explore the world around it. But when we think of the human brain, we think of one big mass, one big piece of very clever jelly. But it's actually several different pieces that work together, kind of like a concert or an orchestra. And different parts of the brain developed at different points in history, different points in our evolution as a species. So we have different functions within the brain. And broadly, these might be expressed as System 1 and System 2. Your System 1 is all about creativity. It's about things we do without really thinking, like dancing, right? If we tried to think about dancing, we probably couldn't do it. System 2, on the other hand, is all about rules. It's about grammar. It's about things like mathematics, things where you need to concentrate and really think about stuff. These two methods of thinking about the world are necessary for daily life and for our civilization. The thing is that System 1, the intuitive, creative way of understanding the world, is how we maintain and update a model of the world, right? It's how we explore the world and understand it. Now, machines traditionally are programmed. They are all about System 2, and that means that traditionally machines are not able to make assumptions about the world. They're not able to explore it and create models for the world like we are. But that is about to change. We can apply structured learning, where we introduce a piece of data to the machine and we say what's, for example, the different traffic signs mean. This one means stop, this one means give way to other traffic, etc. Within a limited area, that kind of way of teaching machines can be useful. The problem is that it isn't very adaptable. If the machine encounters something that is strange or ambiguous or can be taken in multiple ways, the machine is going to find itself in trouble. And it doesn't necessarily have to be something like this, a sort of a trick. It can be something like this. What is this? Is it a circle? Sort of, yes. Was it intended to be a circle? Maybe. Did somebody paint it? Or was it just left behind by a coffee cup? These are questions that as humans we can think about and look at the probability of different ideas and try to make a good guess. Machines traditionally have found this incredibly difficult. These kinds of fuzzy problems are what neural networks are very good at. Now, our brains are built out of networks of neurons. And neural networks are not based upon System 2 mathematical rule-based thinking. They're more like this kind of game, right? Where you fire the balls up and they come down and it's random. Here's an example from an American TV game show.
Right in the middle. The car is right in the middle.
So you understand. This kind of way of putting the little disc down a path that can go one way or can go another is how we can turn the rule-based, structured, logical System 2 way of machines thinking into something much more like human intuition and creativity. This is called artificial neural networks. And we can use these networks to help machines to understand the world the way that we see it. When you're looking at me, and I'm looking at you, our brains, very, very quickly, are picking out certain features, things like edges or the most obvious features, and we put them all together in little pieces, and out of that we build up a picture of someone. And from that, we then might decide that this person is somebody we know or somebody we don't know, and things like that. So we build up a picture and then we put attributes on it. And machines can do something similar with computer vision, picking out the salient features, the features that are most obvious, and then building them up in layers and layers and layers to create a picture of something. And this is how artificial neural networks can be used to recognize certain animals, to tell, for example, a dog from a frog. These algorithms are like a child. They learn from anything that they encounter, right? We try to protect children from the things that they discover because children absorb stuff like a sponge. But to teach algorithms, like with teaching children, we need materials to give them, to teach them about things. Facebook, for example, uses children's books in order to teach their machine intelligence algorithms about the human world, our society, how relationships work, the good guys, the bad guys, conflict, resolution, all that kind of stuff. So we can think of these algorithms as being much like a child's mind. But the thing is that the algorithms need data in order to work. And traditionally, there has been a big lag in the time between when an algorithm is developed and when the data required to make that algorithm useful arrives. It's typically a gap of between 15 years on average. So the algorithms that today are being used for facial recognition or for translating speech, those have been around sometimes for 20 or 25 years, but they've only become useful because of data more recently. So where's all this data coming from? Well, this is a good example. Lara Croft, of course. We can see the increase in the amount of data that is able to be produced, shared, rendered, etc. And we can see just how much difference we've experienced in 20 years. In all of human history, from the time when we were banging rocks together or living in caves, up until the year 2000, we created, as a global civilization, about 5 exabytes of data. It's a huge amount of data, but it took all of human history to make that amount. And yet that same amount of data wasn't taking thousands of years. By the year 2010, it was doubling every 10 hours. And today, it's doubling faster than every 2 minutes. We are drowning in data. We have so much data. Where does it all come from? If you think about YouTube, there is 48 hours of content uploaded to YouTube every single minute. We are producing tons of data. Machines are also producing tons of data, like with IoT. And all of this data then can be cleaned and then used to power machine intelligence algorithms. All of this data is why we are seeing such an explosion in the capabilities and the strengths of machine intelligence in the last couple of years. And that trend is going to continue. We can take all sorts of different data sets, from traffic signs to medical imagery to Chinese writing, etc., and we can begin to enable machines to understand them for the first time and to provide context to them, to understand what is happening in an image. Here, for example, man using his laptop while his cat looks at screen. This was generated by a machine. Machines are creating new understanding about the world, powered by this kind of data. They're even able to predict the motion of an object in the near future, just as we can use our brains to predict what might happen next. Truly, we are living in a new age. In the 19th century, we got water into our homes and we mastered traveling on ships between continents and shipping stuff on canals. In the 20th century, we got power into our homes and we mastered the use of petroleum to drive vehicles. In the 20th century, we have intelligence on tap. Intelligence is now a new utility that anyone can tap into at any time. And as the power of these algorithms increases, the more and more uses that we find for them. It's kind of like electricity. When we first got it into our homes, we were using it just for lighting, and then we found how to use it for heating. And now today we have 100 different devices in our home that all use electricity. We're seeing something similar with the use of machine intelligence today. And it's being used for boring things like this. This video was produced by machine intelligence, right? Upload your holiday videos and Google Photos app can create this kind of montage for you. This is on Pinterest. If you like that lampshade, this machine intelligence is able to recommend similar lampshades that you can buy at that moment. Machine intelligences are now not only able to beat humans at chess, but to learn how to play chess just by watching human players, and to learn it to international master level in only 72 hours. Recently, of course, we saw the victory in Korea with DeepMind's Go playing algorithm beating the humans 4-1. And these same advanced intelligences are now being used for things like real-time translation.
Hola.
So how are you today? What are you doing?
¿Cómo estás hoy? ¿Qué estás haciendo?
What do you do in your free time?
¿Qué haces en tu tiempo libre?
Normalmente viajo, leo
Normally travel.
y hago deporte.
Leo.
So that's a real beta. That's being used by Skype at the moment to do live translation between English and Spanish, as an example. So we've seen how big data, this data that we're drowning in, powers algorithms. We can take that data and we can generate knowledge from it. And we can watch what humans do with that knowledge and how the world works, and we can generate experience. The next level of machine intelligence is thinking about the future and being creative, creating something new that didn't exist before. This is an algorithm that can turn a picture into a story. In this case, the algorithm has been trained on romance novels. Another example. Here, you can turn a sketch that you made in MS Paint into a beautiful painting like this, using a machine intelligence algorithm that is trained on various paintings. And in fact, in the Netherlands, they created a new painting by Rembrandt that Rembrandt himself never painted, but it was based upon all of Rembrandt's paintings. Creative, huh? How about these faces? None of these people actually exist. They were all dreamed into existence by a machine intelligence. And machines can help us to repair data. If you look closely, you'll see the video on the left is fuzzy. It's not very high quality, not very high resolution. On the right, it has been repaired and upscaled using these kinds of algorithms. Again, more and more and more data to come. Do you understand? Picture a brick wall in your mind. Imagine it. A machine can do the same. A machine can imagine textures, for example, for a game without having to be drawn by hand. And we saw how a picture could be turned into a story. We can do the opposite. We can take a piece of text and we can turn it into a picture. Now, at the moment, the picture is kind of a little bit childish, but it's improving all of the time. And if you want to really understand the power of these technologies, take a look at Doomguy and how it was interpreted by machine intelligence. Even extremely rough data is able to be boosted into high fidelity using these algorithms. DeepMind's algorithm, for example, is able to learn new ways of playing the game. Games like this are very useful because they come with a scoring mechanism, and that makes it easy to train. Now, the algorithm starts off being terrible, but after 600 goes, it starts to get quite good, and it generates a new strategy. You see? To go up the top. And in case you thought that that was just a fluke, just an accident, no, it knows. It knows what it's doing. And we can do more than just play Atari games. We can begin to navigate complex 3D worlds using these technologies. Not just game engines like this, but very complex things like autonomous vehicles. Vehicles can now understand the world around them and fly within a forest without hitting into things. At Singularity University, where I'm on the faculty, we have a startup there that's being accelerated that is using these sorts of technologies to kind of machine gun seedlings into the ground, into places that have been deforested, and to repair the damage that was done. Another good example of a green robot. This is Cotspot. Cotspot is crown of thorns starfish bot, and they use it off the coast of Australia. These circles are called HAR wavelets. It's a machine vision technique, but it roams around autonomously in the ocean, murdering starfish. These are an invasive species that damage the coral reefs. And this robot, all by itself, identifies them and destroys them. So we see that robots can be used to help improve the world and improve our environment. But robots are deceptive. This looks very powerful, and yet here is an example of a robot trying to do something designed for a human to do. This is at DARPA's recent robot challenge a few months ago. Ooh, whoops. Yeah. Now you can look at that and you can think, well, that kind of sucks. But I want to show you what an autonomous car was capable of 6 years ago. 6 years ago. Dope. Not very impressive. What about today? This is a Tesla on the highway, and an idiot human pulls out in front, and the machine is able to react faster than a human ever could. 6 years from terrible to superhuman. How? The machine isn't just learning on its own. It's sharing all of the information and its experiences with other autonomous vehicles. They're learning together, and all of that information comes into one place. This is why machine intelligence can be mistaken. You can look at it and think, this isn't going to be ready for years. And yet, before you know it, it's become superhuman. This is the meaning of disruptive technologies. The next stage is teaching robots how to move within our world. So here we have a kindergarten for robots, where the robots are learning just like a very young child. Robots are able to understand the shells, the bodies that they find themselves in, and how to move within those bodies. And they can do it physically, or they can do it in a virtual world. In a virtual world, it can run 1,000 times faster than real life. And so machines are able to learn very quickly by playing within virtual worlds. These kinds of experiences for machine intelligences are creating things like Watson, IBM's knowledge engine, for example. But this isn't just to be used for business purposes. Here's one example that's much more close to home.
Welcome to New York, Barbie.
I love New York. Don't you? Tell me, what's your favorite part about the city? The food, the fashion, or the sights?
Ooh, the food and the restaurants.
I love the food. Where else can you find so many types?
Intelligence is coming out of the cloud, and it's becoming embedded. And pretty soon, your children may be asking difficult philosophical questions not to you, but to Barbie. And Barbie will be collecting all of that information and learning about human beings in interesting ways. Recent advances in graphical processing for mobile devices are bringing these kinds of intelligences to the devices themselves, taking it out of the cloud. For example, the shoes that I'm wearing today are made in India. They're called lechels, and they have computers in them. And these computers help me to guide around a new city by vibrating, for example, whenever I reach a corner, turn left, turn right, etc. So we're starting to see intelligence being embedded into devices all around the world, even the most simple devices. If we want to understand the meaning of machine intelligence in the near future, it doesn't look like this, right? Server banks in some cloud hosted somewhere. It looks more like this, like plankton in the ocean. Lots of tiny, tiny little stupid intelligences, but all of them smart in their own way, and all of them interacting in an ecosystem together. This is OpenWorm. It is the first digital life form. It is replicated, all 302 neurons, a very, very stupid creature, but it is digital life. And you can take this digital life and you can put it back into a robot. So we have a digital copy of a real life form that is back in a robot and able to navigate the world. And as far as it knows, it is a worm. It is a real worm. And this is the beginning of the exponential growth of computing, where we start being able to reach insect brains, and then within a couple of years, mouse brains, and before long, something like the human brain. But there are limitations. Here, for example, we have a machine intelligence that is giving us a picture of what it thinks a dumbbell looks like, a weight for gymnastics. And you see it's got an arm attached. That's an example of something called overfitting, right? Because a lot of pictures of dumbbells have people holding them. Here we have more examples of things that are sort of right, but not, right? They're close, but no cigar. And so we see that getting close to something is easy, but getting it precisely is very hard. And that's why for a long time, we're going to have humans in the loop. We're going to have humans and machines working together, right? Just like adult supervision for children. And this is called cobotics. Humans and machines working as partners. And we won't just be guiding machines. Machines will be guiding us. Here, for example, is Google's Goals. It's a calendar application that can help you to achieve the things you want to, like going to the gym, by finding good times to pursue those goals, right? Giving you a little nudge in the right direction. Machines are now starting to understand us as human beings. They're starting to understand our values, our personalities. Pretty soon they will know us better than we know ourselves, perhaps. Here's another example.
My kids keep me going.
What advice would you have given yourself 10 or 20 years ago?
As a virtual counselor.
To not believe, to not be so gullible, to not be so gullible.
But if machines are to guide us in life and to truly understand us and work with us as partners, they need to understand ethics. They need to understand our morals. Just like children, we need to teach them morals. We need to teach them right and wrong. And we're already seeing some problems from machines. For example, a telephone robot that has recorded human voice lines, but it's controlled by a machine, can ring you up. And if you ask it, are you a robot, it will deny. It will say, no, I'm not a robot. Of course I'm a real person. This is happening today. We're also seeing problems with devices that lie to the authorities, for example, about the emissions, right? They detect whenever they're being questioned and they deny everything. If we are to improve human relationships with each other, we can make the best of machines. We can make the most of machines in helping us to mediate those relationships. But we need to make machines ethical and trustworthy. That's how we bring the joys of machine intelligence to everyone in our society. Thank you. We might have time for
Thank
a
you.
question
Do
or
you have
two.
any questions? Вопросы?
Yeah, thank you. Just yesterday I heard one joke about doctors that a patient comes to a doctor and the patient knows that the second and the later visits are cheaper than the first one. So he pretends he has been to the doctor already and he says, "Hi doctor, it's me again. So how's my, for example, leg doing?" but the doctor says, well, just keep taking the pills I prescribed you the previous time. So what do you think? That's just like the counselor, you know, the one. Do you think this artificial intelligence will help solve some mental issues, just, I mean, light mental issues, of course, not organic, but like light psychiatry? Will it be helpful? Because hundreds of doctors just earn their money this way. They just say, okay, go on, yeah. That's
I think that those kinds of talk therapies are incredibly valuable, but they're very expensive and they take a long time, and there are not so many people that are really skilled at it. I think that these kinds of technologies can truly revolutionize our society by making us all healthier and happier people. And I think that's one of the core messages that I would like to share today, is that we can use these technologies to really reshape our world in a better way.
It looks like presence of a human being is pretty bad for the planet, and if we think a little bit about this, we can, like, from one button destroy everybody and everything, and even the planet. If the artificial intelligence in 30 years or 40 years will be smarter than human, what is the reason for keeping humans alive just because the humans can destroy everything around them just pushing one button?
It's a very good question. A truly ethical machine may be concerned about the whole of Earth's biosphere and might have a problem with some of the things that humans do, for example, to animals. Also, an ethical machine might still decide to defend itself against humans that decide to attack it or try to force it into a box. These are some of the greatest problems that humanity will face in the next 20, 30 to 40 years. They're big problems. We don't have answers. Some people are trying very hard to find answers. For example, the Machine Intelligence Research Institute. I'm also, in my own small way, trying to help figure that stuff out. If you'd like to learn more, please come and we'll have a chat later. Thank you.
Hi, Nell. Long time ago.
Hi.
Hello, hello. I have a very simple question. So what about cybersecurity, and what about protection of our privacy? For example, you showed us a very interesting example of Barbie, which is coming up on the market. So would you like a mom to buy such kind of doll to your daughter, knowing that somebody can hack it? So what about this kind of problem?
Yeah. We have seen toys like Barbie or similar things being hacked and people using them to listen in. Baby monitors, for example, being hacked as well. This is a big problem. And it's only going to get worse. We're now seeing algorithms, of course, that can look at somebody's random face and then put a name to that face, for example. I think that one of the best ways of protecting ourselves is to have a kind of a digital immune system. And I think that machine intelligence, hopefully, can help provide answers, basically being a sort of a white knight that can help to defend us against these kinds of problems.
And do you see any business opportunities here for entrepreneurs? For example, you as an entrepreneur, very much doing
Absolutely,
this topic.
Absolutely. As Marvin mentioned, security is a big deal, right? And we're not seeing so many really interesting companies in these kinds of space. I think there's a lot of room for new ones and for greater ones. I would love to see more companies doing security, AI-related stuff, big time.
Еще вопросы? Да. Даша, вот там.
Thank you. My question is, how do we allow machines to make mistakes? Because we seem to have a very low tolerance for mistakes when it comes to machine. Well, let's say take Google car or like the latest psychology example. Let's say tomorrow I'm making a startup of the virtual psychologist, leveraging the fact that in Russia it's not licensed. But like we really can do harm. And what are the criteria we can put here? How do we understand where we can allow the machine to explore the world, to make mistake, and where we should control it?
Yeah. For a long time, for a very long time perhaps, mistakes made by machines are going to be unavoidable. Now, there will come a time, like with the autonomous cars, where machines make less mistakes on average than humans. And I don't think we need perfect machines. We just need machines that are about as stupid as humans can be sometimes, right? So long as we get to that level, I think that's fair. There is a need for supervised autonomy, a need for adult supervision of these algorithms. Because algorithms are like children, they drink in data like a sponge. They can be influenced by human problems, like if data has trends within it that are basically racist or that sort of thing, the algorithm is going to take that in and then replicate it again, right? And so we have to be careful about what data that we actually expose algorithms to. This is another big problem area, and I think that curating data, cleaning it, making it better, validating it, is going to be one of the key growth areas over the next 5 to 10 years.
And can I have another one? So do you think that society is going to change its approach? Because to me now it looks like that there is a small amount of tech guys who understand that machines are actually doing better in general than an average human, but society itself is not accepting machines to make any mistakes. That's why society is against like self-driven car and stuff like that.
Yes, I think it's a shame how we expect machines to be perfect, especially right out of the box. I thought that Elon Musk's decision to enable autonomous features on his Tesla cars in beta was an incredibly brave move, right? I mean, it's a beta, it's flawed, and yet, use it on the highway, right? And of course it worked out, because very quickly the machines were able to learn, all of them, thousands of them sharing information. I would like to see more courage like that, because I think that taking that kind of initiative can really help us get up the curve in terms of what machine intelligence is capable of.
Thank you.
Thank you.
Так, у нас есть первый вопрос из Твиттера. The first question via.
So we have the first question from Twitter.
So what companies are the most successful on the market now of artificial intelligence market?
A lot of it is relating to things like logistics or warehouse management or predictive policing, being able to guess when, where, and what kind of crime is about to happen and get some police there before it does happen. I think those are some of the most exciting areas. I'm very interested in machine vision, helping machines to understand the world. You remember the video? One of the videos was kind of fuzzy and damaged, and the other video was cleaned up by the algorithm. I think that those kinds of areas looking at the 3D world, using 3D sensors, is also very exciting. Using the imaginative ability of machines to fill in missing data. I think that's also going to be a key growth area in the coming years.
Okay, thank you very much, Nell.